All right, so we are now onto the stage where we're going to be building the LED flasher, and we'll be using the microcontroller to flash the LED. So first of all, let me introduce the components before you. This is our battery, 9-volt battery. This is our main guy. This is the 16F72 microcontroller. This is the 7805 voltage regulator, and of course this is our LED here, and this is our resistor. These are jumper wires, breadboard, and then the circuit. We built this, we designed the circuit already. So we'll be following the circuit step by step, and then we'll be building everything. First of all, the first major component to put on this circuit is the microcontroller. So you already know how to use breadboard. You don't put it here. You don't put the IC here. You put it at the center, anywhere along this track. I would not like to put it here because it's too close to the side, and don't put it here, it's too close. Just get a central position like this and put it. Alright, the next thing is we can put the clock. This is the 4 megahertz clock. The clock is on pin 9 and pin 10. If you look closely, pin 9 and 10. So we have to count. I taught you how to count IC pins. So to do the count, let's use this jumper wire to count. This is pin 1, 2. Looking at this dot and where this U shape is, we'll start from here. Pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, 9, 10, 9, 10, 9, 10. So this is where we're going to put the clock. See that? It goes there. Alright. Next is the resistor. The resistor goes from pin B2. If you look close, it goes from pin RB2, sorry. Pin RB2 means pin 23. Here, if you look closely, you see it's pin 23 there. So we have to trace pin 23, and I don't need to start counting from 1 to 3. I already know that this is pin 1. I know this is pin 14. So since I'm going this way, I know that this is pin 15. So I can start counting from here. 15, 16, 17, 18, 19, 20, 21, 22, 23. Alright, we have arrived at our destination. And then where am I going to put the other leg of the LED? First of all, from the circuit diagram, the other leg of the resistor, I'm trying to fix the other leg of the resistor now. The other leg of the resistor goes to the positive of the LED. So I don't know where I'm going to put my LED, so I have to decide. I've not put my LED yet, so I need to put the LED now so that I can know where to drop this leg, because it must go to this positive. This is positive of the LED, this is negative, longer leg, shorter leg. Let's put the LED here, not too far away. Remember, well, you should already know how to use breadboards from the getting started in electronics. So I won't bother explaining those. So now the resistor leg can drop down here. Alright. That's okay. The next thing is, we're done with this and this, but we've not connected the LED to the battery yet. So we've connected the clock, where's my pen? Okay, we've connected the LED resistor, we've connected the LED, we've connected the microcontroller, we've connected the clock. The next thing we need to do is this, and this. Let's deal with the 7805. This is 7805. This is the pin 1, pin 2, pin 3. Pin 1, 2, 3. So from this diagram here, you have pin 1, pin 2, pin 3. So we need to take note of it. Pin 1 is the input, 2 is the ground, 3 is the output. So I can put it somewhere around here. Not too far, not too close either. Just there, or let's take it a little bit closer. Careful. You see the way I'm shaking it so that if you just don't force it in, otherwise the leg will bend. You just shake it, because if you are using a new breadboard, the holes might be very tight because they're still virgins. So you need to be gentle. All right, next, we've done this. The next is to connect the 10 kilo ohms resistor. Where is our 10 kilo ohm resistor? Oh, sorry, we forgot it. This is it, 10 kilo ohms. I don't need to measure it, I already know it's 10 kilo ohms, but you can measure if you want. From pin 1, it goes from pin 1 there to pin 3 of the regulator. This is the pin 3 of the regulator. This is pin 1, 2, 3. Pin 3 to pin 1. Pin 3 to pin 1. So I can stretch it from here to here. That's exactly what I'm going to do. From here, there. All right. So that's done. Take it. Next is the battery. Let's leave the jumper wires first. We'll deal with them soon. Let us deal with the battery. This is a breadboard, so there are many ways I can connect this battery, but let me do it the traditional way. I'll use these 2 tracks here. Remember, these 2 tracks are not touching each other. They are parallel to each other, but they are both interrupted here, so that the remaining tracks here are not connected to these ones. These ones are not connected to these ones, and this one is not connected to this one. So let's just put the ground here and put the positive here. So we have our let's put positive here. So we have our power in now. The next thing we need to do is now we can take here. Next thing is to wire up the whole circuit, connect everything. To do that, which of the wires have we not connected? All right, let's deal with all the wires now. First of all, let us take the pin 3 to pin 20 here. Pin 20 of the microcontroller is the power of the microcontroller, the VDD. So we have to take the pin 3 to this pin 20. It's very simple. Just take one of these jumper wires. Locate pin 20. From experience, okay, let's not use experience. Count again. 15, 16, 17, 18, 19, 20. Sorry, 15, 16, 17, 18, 19, and 20 here. Simple. And then the other end of the wire goes to pin 3 of the regulator. That's my pin 3 there. As you can see, it's on the same line with this resistor the same, with pin 3 the same. So I have my power there. Next, we connect the LED, the LED ground connected to the negative of the battery. Where is the LED ground? Okay, this is it. We don't really need to go as far as going to the negative of the battery. The negative of the battery is also going to come to the negative of the regulator, that's pin 2. So we can afford to put the LED ground here. See, it's on pin 2, because I already know that the battery negative is also coming to that pin 2. So there's no need to waste my time. So now I'm taking the battery negative and I'm putting it on pin 2. Alright, let's get the wires out of the way so you can see. Alright, so we've connected this wire. Stick it up. Connected this wire. We've connected this wire. We're yet to connect these 2 wires. So let us connect those 2 wires. First of all, we can use this pin 19 and pin 8 are connected together, and then they both go to ground. So this is pin 19 because this is pin 20, so this is going to be pin 19, and then you can take it to pin 8. Where is pin 8? 1 2 3 4 5 6 7 8. So pin 8 is here, so you just drop it there. All right, everything still looks okay. The next step is to take pin 8 now to ground, and to do that we need another jumper wire. Let me get another jumper wire. Alright, found some. Pin 8, where are you? Okay. Alright, to ground. Everywhere here is my ground, so I can put it there. Alright, so we're getting close to the end of the circuit. All that is left is one last thing. The positive now of the battery is not connected to the circuit at all, so we need to do that, and that's going to be very simple. All we need to do is put this on pin 1, because pin 1 is the input of the regulator, and then I pulled out the positive from here because now it's going straight to pin 3, and as soon as I plug this thing, that LED has to flash. If the LED does not flash, then it means either I don't know what I'm doing, or we made a mistake somewhere, and we'll trace our steps back. So let's see if I know what I'm doing. Okay, so the LED is flashing. We can try again. Alright, so I'm going to do something very funny now. I'll remove that 4 megahertz clock and put a 20 megahertz clock, and let's see what happens to the speed of the LED flashing. So let's get it 20 megahertz. All right, this this is a 20 megahertz clock. First of all, you will notice that when I pull out the clock, something will happen. When I put it back and remove it, something will happen. This means without the clock, the microcontroller cannot execute any line of code. Now let me put it 20 megahertz. See, it's twice, it's faster. It's actually 4 times faster than the way it was before. And then back to 4 megahertz. All right, so that's for the LED flasher. I like the faster one. It's more interesting. All right, show is over.